If you're finding that you don't have enough time to run a quality QSRA, quantitative schedule risk analysis, not only will you consistently be functioning in a stressful situation, you're also missing out on the possibility of adding additional value to your project. Hi, my name's Chris Ritson. I'm the Senior Risk and Uncertainty Consultant here at Safran Risk. As an experienced project risk manager, I've had the opportunity to utilize various risk management and risk analysis Monte Carlo tools for highways, major civil engineering, rail and tunnelling projects. And with that being said, I can completely relate to how difficult it is to ensure that all the required components of a QSRA are in place in a timely manner. Coordinating the latest schedule in tandem with the appropriate cost estimates and associated risk register, whilst also understanding the latest evolved project requirements, is no simple task. All of this is in combination with change management and can impact the amount of time that we have set aside to do justice to a quality quantitative schedule risk analysis. And due to an immense lack of time, there is a chance that we could find ourselves in a garbage in, garbage out modelling situation. This is why I'd like to highlight and share my top 5 time savers that I found using Safran Risk that will likely resonate with my fellow project risk managers facing a QSRA deadline. And in my second video, I'll go on to cover just a few ways that you can utilise that time saved to add value to your projects with relative ease. So if you've ever run quantitative schedule risk analysis before, this process will be familiar to you. We start with importing or creating the schedule, validating for integrity, modelling the risks and uncertainties, reviewing the results against a particular confidence value and maybe looking at the drivers against certain milestones. But as you spot issues within the model and you run through steps 2, 3, 4 again, iteratively refining the model until you're in a position to finally communicate it to the project stakeholders who then use their experience to challenge your outputs and results. However, this fairly linear looking process is often done under a time constraint, and that time constraint means that we're not always delivering the best value we could. Ideally, we risk professionals would be able to provide additional support to our decision-making leadership by giving them actual alternatives to consider, whilst also providing some recommendations. This would provide them with more meaningful choices, which hopefully elevates how the risk function is perceived in the business by finding and measuring value that was previously hidden from view. If contributing teams and subject matter experts are unable to provide their modelling data inputs any sooner, then the only logical way we can provide this added value is, frankly, if we start saving the time ourselves. So here are my top 5 time savers that I've discovered whilst using Safran Risk. There's intuitive design, historical actuals, automated feedback, detective mode, and modern computing. The first is intuitive design, especially in regard to the workflow. You can see that Safran Risk shows all the model inputs on the left-hand side, setting up your analysis options in the center, and moving through to your outputs on the right-hand side. In conjunction with the visual feedback mechanisms that I'll share soon, this workflow layout helps us to quickly see where we are in the process of building our schedule risk analysis model. And by that, I don't just mean risk professionals, but the wider team as well. This means that it's even easier to work more collaboratively in, say, a risk workshop environment, as others can follow the breadcrumbs, so to speak, with a net result that we can actually loop around steps 2, 3, and 4 of the iteration cycle far fewer times because collaborators are spotting the anomalies and issues with the inputs before we actually run the Monte Carlo simulation, which inherently saves time. It grows team trust in the model input and may even save time later if multiple contractual parties have co-created the model together. Individuals are less likely to challenge the outputs later. The next time saver is what I like to refer to as historical actuals. Throughout my career, I've been trying to get people to look at the historical precedents for the risks that they're actually talking about. Are they common and typical? But also, I'm trying to nudge organizations to look at their supply chain partners, the ones that they often use time and time again, which means they've probably got historical evidence of the past performance, the base uncertainty range that they're predicting for future projects. So building these up over time for your subcontractors, say A, B, and C as shown in the picture here, you can quickly and easily map and apply those ranges to portions of the project schedule later via the risk mapping screen. Another example of both using historical evidence and a bit of automation is that you can copy and paste information from real life telemetry, say from a weather station, directly into Safran Risk. When you do this to, say, create a weather calendar, you can even take what might be a shorter sample period, but then extrapolate it over a longer project term using the Monte Carlo method. So something like a 1-year data sample could be made good for a 5 or 10-year project, for example. Automated feedback is another key time saver. It's easy to set up conditional formatting in your schedule view. So here we can see the constraints in yellow, but also the darker blues advising us of some potential nodal or merge bias hotspots to look out for. And of course, the actual schedule warnings themselves are automated as well. So they appear as you're building your schedule or as if you've imported it and are making changes to it. The warnings will self-detect and flag up with convenient hyperlinks to assist navigation, remedying the warnings as necessary. We can also show the notes behind our thinking of what needs to change and why, meaning that we can save even more time by exporting to Excel and attaching that then as a handy appendix to our QSRA report later, rather than double handling the information. There's ample opportunity within this workflow for feedback. The best for me is seen here in the risk mapping screen, where you can see how multiple risks and uncertainties combine together to create a unique distribution, such as the one shown in the bottom right of the screen. This is a 1000 iteration automated Monte Carlo, limited to just one activity and its mapped risks. This means that teams can see and react to this and ask, does this feel right? Another advantage of this screen is that you can actually change the orientation and the way the data is presenting itself. So here I've assigned user fields for low, medium and high to help us quickly apply low, medium and high estimating uncertainties. However, we could just as easily use a work breakdown structure or some other metadata. Another example of automated feedback occurs when you're setting correlations. There's a couple of things here. One is that we can use the filters intelligently and then apply correlation coefficient value to multiple items all at the same time, rather than having to do it on a cell by cell on the matrix. And another example is when it does detect an issue with the underlying input values, it will automatically warn you about these. It won't let you run the Monte Carlo until you've either fixed it yourself or used the replace with suggested autofill. The sensitivity analysis is one of the better examples of how Safran Risk automates a laborious task that you wish was done easier. And when you do this manually, you may accidentally introduce human error, of course, as well, which can be a drag on your time later if you have to reperform a bodged analysis. But what we have here with Safran's sensitivity analysis by exclusion method, as advocated by David Hewlett, is essentially knocking out one risk at a time, then measuring the delta. So the more risks you've included in your model, the longer it takes, particularly on other software packages. But here, it just automates the process. You hit calculate button, it will go through and revisit the existing Monte Carlo that you've already run. Or if you want to refine the output further, you can actually run a multiple pass method instead, which will then run additional Monte Carlo simulations as well. Or if you're like me and you champion Pareto principle or the 80-20 rule, then you can limit the number of additional simulations to just say the top X number of risks. So that's a time saver within a time saver. So detective mode isn't actually an official term for Safran Risk. It's just what I've been calling it since I've started demonstrating the product. I mean, QSRA essentially tests the hypothesis that the project objectives are achievable and where the problem arises before they do so in real life execution of the project, and for a fraction of the cost of inventing, say, time travel. So to explain this, this is where you can delve into the underlying raw data from the simulation output. You can see which tasks occurred on which iteration, look for patterns and see if there's any scenarios or risks that conspire together to push the project towards unacceptable project outcomes. You can even click on the iteration hyperlink to take you back to a read-only view of the project in that particular iteration. So you can see the risk-adjusted Gantt chart with grey bars representing the deterministic schedule position, the green being the P50, the salmon pink the P80, and then just look how far across to the right-hand side this iteration actually is in terms of its critical path, comparatively. You can actually see the risks that have impacted and also what the durations were for each of the activities on this screen too. So this extra tool in your tool belt helps you understand your modelling scenarios, or once you've actually run the model and can tell that something isn't behaving as expected, it helps you find those needles in the haystack. Safran Risk is a modern software package that is under continuous development by the team, always listening and taking suggestions from our customers and trying to improve it further. It's stable on Windows 10 and it's secure because it's regularly patched and updated, etc. So the platform itself is sound and it runs fast, really fast. I think you'd notice this if you were to import much larger schedules, in the sort of tens of thousands of activities. And of course, one of the reasons that people opted for high-level generic schedules as a standard preferred approach was simply because the tools that you'd been using in the past actually didn't accept the tens of thousands of line items without falling over and crashing. Or they would take up so long to run, you'd run them overnight, not knowing if they were going to crash. You wake up in the morning, see if it worked or not. Those kinds of days are behind us now because modern computing platforms are much better set up for this kind of level of sophistication and complexity. So you can now identify the exact hotspots and bottlenecks within your actual delivery schedule rather than losing the granularity through a generic top-down impression and expression of the schedule. So as you move from embryonic stage of a project with a few hundred activities and the details start getting added, I'd encourage you to save time by not needing to administer a separate high-level QSRA schedule in tandem to your actual delivery schedule. But another significant advantage is that where the hardware is also improved, we can now use multiple CPU cores, etc., which means that Safran will use these and it allows the Monte Carlo sampling to go even faster. I mean, it seldom takes more than just a few minutes to run a full Monte Carlo model for a project. And actually, it will even import your .xer files from P6 faster than Oracle PRA. That change in the power of modern computing platforms enables the fast creation of hybrid scenarios. So not just pre and then post mitigated positions, but Safran also enables probabilistic blended approach to both pre and post in the same simulation. So there's lots of things that you can do here that you just can't do elsewhere, and you might see them as being soft what-if scenarios, for instance. We want to increase the value on our projects by reinvesting the time we've just saved to do more exploratory work in order to provide more contextual and targeted recommendations that decision makers feed back into the actual execution of the project to make a real tangible difference to project outcomes, which I'll cover in the next video. So please feel free to visit safran.com to read some of the blogs, other user cases, or maybe you are interested in attending free online learning session, 30-day trial download. In the meantime, I'd just like to say thank you for taking some of your valuable time to join me today. I hope you'll be sure to check out the next video in this series.